Okay, so welcome back. I know the last lesson was challenging, okay, and it should be. We're getting into kind of the more difficult parts of chemistry. So we're not looking at anything new today. We're just going to continue on with stoichiometry, but now we're going to kind of take the problems that were kind of perfectly set up for us and kind of put them into word problems. So it's not really going to change much. Okay. So right now this is our final lesson on stoichiometry. Okay, so if you hate this stuff, this is the last lesson. Get through it. Now, we should now know the basics of doing stoichiometry questions. Okay, the next step is to be able to take like real life problems and then apply our skill to apply this table to a real life problem. Basically, be able to create the chart and then use it. Before, the last learning check was here's the chart, just fill it out. Now it's okay, I'm going to give you a question. I want you to fill out and actually make the chart. So an example would be like here, where I say, here's the question: carbon tetrachloride. Okay, or sorry, tetrahydride, CH4, or methane or natural gas, burns with oxygen to create carbon dioxide and water vapor. Now, with the C's, I will be giving you the balanced chemical equation. Okay, so here's the balanced chemical equation. It's basically saying if I burn 100 grams of CH4, how many grams of oxygen and carbon dioxide and water will I have? Okay, so what we're going to do is it's the same kind of thing. Now we just have to actually make the table on our own. Okay, so I've kind of already gone through and kind of put this in here. So let's go through and do this question. So the first thing we're going to do is we're going to fill out the table. So I make the table and then I say, okay, CH4 plus 2O2 leads to CO2 plus 2 H2O. Then it says if I have 100 grams, so how many grams? I have 100 grams. And basically, I need to get the answer of how many grams here, here, and here. That's the goal in this question. Okay. Well, going through, we're going to do the exact, we're at this point now where we're just doing the stuff we did the last learning checks. Now I got to go through and figure out the molar mass of all these things. So if I look at carbon tetrahydride, that's going to be 16.05. grams per mole. 2 oxygens is going to be 32. CO2, so oxygens are going to be 32 plus the carbon is 44. So 44 grams per mole. 44 grams per mole. And then the water, one that I have memorized, 18.02 grams per mole. Now I've got these all figured out. Okay, I can really only do one calculation right now, which is going to be getting the number of moles. So I'm going to take 100 grams and divide it by 16.05. So let's do this. 100 divided by 16.05. And I got 6.23 moles. But now I want to figure out the number of moles of oxygen. So in order to do that, I'm going to have to multiply by my fraction. And the fraction in this case happens to be 2 over 1. So that's going to be 12.04 moles. Sorry, 12.4 moles. Okay. And then if I want to get the number of moles here, I'm going to have to multiply by 1 over 1, so it's the same, so that's going to be 6.2 moles. And then if I want to get all the way down here, I'm going to have to multiply by 2 over 1. So 2 over 1, which is going to be the 12.4. Okay. Now all I have to do now with my remaining is just to multiply to go back up. So whenever I go down, I divide. When I go back up, I multiply. So 32 times 12.4 equals 32 times 12.4. So I'm going to need a lot of oxygen. I'm going to need 396.8 grams of oxygen to combine with 100 grams of natural gas. And how much CO2 is that going to produce? Well, I take 6.02 and I multiply it by 44. I get 264. 264.8. And my last one down here, 12.4 times 18.02 equals 223.4. And it's always good to just make sure that we check. So if I add up these two things, so we're looking at 396, so we'll say that's 400, add another, that's 500. So 500 on this side, and it looks like I have roughly 500 on the product side, so I know I've done my question right. Okay, so that's a C-type question. Oops. Now with the U's, it's going to be slightly different. It's going to be a little bit more challenging, where I won't give you the equation. I'll say something like this. Magnesium oxide reacts with fluorine gas to create magnesium fluoride and oxygen gas. If I have 35 grams of magnesium oxide was used, how much oxygen gas will I create, and how much magnesium fluoride? So in this case, it's a little bit more challenging because you have to create the formula. So this is, remember, you have to know this crisscross rule. So magnesium oxide reacts with fluorine gas. So magnesium oxide is MgO plus fluorine gas, and that's F2, leads to magnesium fluoride, which is going to be MgF2 plus oxygen gas, and that has to be O2. So this is extremely important that you get this part right. Okay, if you get this part wrong, then everything else in your question is going to be wrong. You need to make sure that you have the formulas right, and then on top of that, we now need to make sure that we've balanced it. Okay. So if we look, my magnesiums, I have one on the left, one on the right. That's good. If I look at oxygens, I have one here, I have two there. That's not going to work. I'm going to have to put a 2 there. Let me pick a better color. Put a 2 there. That's going to throw off my magnesium, so I'm going to have to put a 2 there. It's going to throw off my fluorines. If I put a 2 there, I'm thinking everything's balanced now. I've got 2 magnesiums, 2 magnesiums, 2 oxygens, 2 oxygens, 4 fluorines, 4 fluorines. Okay, now everything's balanced. Now it says if 35 grams of magnesium oxide, so here's my 35 grams, and I need to know blank, blank, blank. That's what I want to know. Okay. So I'm going to go through, and I've got to figure out my molar mass of magnesium oxide. So that's going to be 24 plus 16 is going to be 40 grams per mole, plus 2 fluorines, so that's going to be 38. Magnesium fluoride, so that's going to be 38 plus 24, 72. Let me just make sure. 38 plus 24. 62. Good thing. My mental math's not very good. Been out of school too much. 62 grams per mole. Then my last one, oxygen, is going to be 32 grams per mole. Okay. So now all I do is I divide 35 by 40 to get my number of moles. 35 divided by 40. And I get 0.9 moles. Okay. So now if I want to figure out this one right here, I multiply by a fraction. It happens to be 2 over 2. So 2 over 2 is the same as 1, so that's going to be 0.9 moles. If I want to get down here, I again multiply by 2 over 2, so that's also going to be 0.9 moles. My last one, though, when I want to go all the way down here, I'm going to need to multiply by 1, because there's no number in front of the oxygen, over 2, or a half, so this is going to be 0.45 moles. Now I just need to multiply these things up in order to get my masses. So 0.9 times 38, 34.2. Okay. Then I have 0.9 multiplied by 62. I get 55.8 grams. Then 0.45 times 32. 14.4. Okay, and it's always good to make sure that these two things add up. So if I add these two things together, we're at like 70. If I add these two things together, we're also at around 70. So it makes my equation, makes me a little bit more confident that I did this correctly. Okay, so what this is saying is that you would need to use 34.2 grams of fluorine, and that will produce 55.8 grams of magnesium fluoride and 14.4 grams of oxygen. Okay, thanks. And again, email me with any questions.